Good morning, children. It's Sanjeev Pal from Srimati LPSAVANI VIDHYABHAVAN, your statistic educator, welcoming you all to the class of statistics. Okay, here, children, now we are going to look forward to our third chapter of the second part, that is normal distribution. Right now, over here, what we are going to study in the normal distribution. We are first of all going to look forward to introduction, why normal distribution, right? We are also going to see what do we mean by probability density function, right? Then after the probability density function, we are going to see what do we mean by standard normal variable and standard normal distribution. In fact, what is normal distribution and what is standard normal distribution, that we are going to study, right? We are also going to see that how say the different areas or the probability could be found out with the help of the table of a standard normal curve. The standard normal curve is given at the last page of your textbook, right? From that, how we can find out the area and how it could be used into the sums, that we are going to see. We are also going to see the properties of the normal distribution and the properties of the standard normal distribution. The properties of the normal distribution and the standard normal distribution are really important. That could be used and can be manipulated and can be asked, say in section A, say in section B, or you can say for short sums. Okay, those properties could be used and could be asked. Right, so we are going to see over here in this chapter what do we mean by normal distribution, where the normal distribution are used, why the standard normal distribution, what are the properties of normal and standard normal distribution, and its examples. Children, in the last chapter, we have studied the probability distribution, okay, for a discrete random variable. Now in this chapter, what we are going to study is that we are going to talk about, say, the probability distribution for a continuous random variable, that if it is a continuous random variable, how the probability distribution could be say found out, or it could be used. Now you would find that what do we mean, we are going to see now what do we mean by a continuous random variable. You will find that if a random variable x, okay, if it assumes any value, okay, of a real number or of a set of real numbers. Now you know what we mean by real numbers, right? So you would find that if a random variable x can assume any value of a real set r, or you can say within the interval of real numbers, then it is called what? It is called continuous random variable, right? And on the basis of that, say a function for obtaining the probability that a continuous random variable assumes value between the specified interval is called the probability density function. So what is the probability density function? It is a function, okay, for obtaining the probability where it finds with the continuous random variable between specified intervals. Now for the probability density function, you would find, we are going to talk about two conditions when say the probability density function could be applied. So there are two conditions for that. First of all, the first condition, okay, that what we are going to talk about is that the probability, okay, or the value of the random variable which lies between the specified intervals, you would find it should always be a non-negative real number. It should always be a non-negative real number. So that is the first condition. Say whatever the probability you are getting, it should be a non-negative one. Okay. Secondly, you would find the whatever the probability that you are getting, or which is say within the given range, the total probability you would find will always be equal to 1. While we talk about, say, the total probability of the random variable, it will always assume the value say that is actually say 1. Okay, that is the total probability would always be equal to 1. So this two conditions are there for the normal distribution, or you can say for say the probability density function, that first of all it should be, say, the non-negative, the value of the probability should be non-negative, and the second one, that the total probability should always be equal to 1. Now yes, children, we are going to see probability density function. The probability density function, you would find it is denoted by fx, right, where you would find the mean is denoted by mu and the standard deviation is denoted by sigma, right, and probability density function is denoted by fx. Now children, from the point of view of the examination, you would find that if I talk about this formula will only be related to the short sums. Got that clear? Okay, that big sums won't be there related to this formula, right? So fx, while I talk about the fx, it is actually probability density function, and you would find while we talk about the formula, it is 1 upon sigma under root say 2 pi into e as say raised to minus half into bracket x minus mu upon sigma whole square, where you would find that sigma is actually the standard deviation, and while we talk about say the mu is actually the mean, where you would find that x will always lie in between the negative infinity and positive infinity. Okay, so, similarly you would find while we talk about say the mean, it will also lie in between say the negative infinity and the positive infinity, and while I talk about say the sigma, it will always be a value say a positive value. Okay, now while we talk about say pi, you know that it's always a constant term or constant value. It has always a constant value, that is pi is equal to 3.1416, and while we talk about say the error, that is e, it will always be 2.7183. Even these values or the constants could be asked into your examination in section B, right? Now if we move further, okay, we talk about say the probability density function fx. Now how this fx, okay, could be basically drawn into a curve, right? So this is how, okay, it could be drawn. The fx or probability function could be drawn. Probability density function in fact could be drawn with the help of the curve. It is always a symmetrical diagram, right? Where you would find in between it is x is equal to actually mu, and both the ends, you know that they are not meeting the x-axis, and that's why there is on the left hand side it's your negative infinity, and on your right hand side is your positive infinity. What the negative and the positive sign shows? The negative sign always shows the left hand side, and the positive sign always shows the right hand side. Okay, here children, we talked about say the normal distribution. Now we are going to see about say the standard normal distribution. Now how the normal distribution could be converted into say the standard normal distribution, or you can say how the normal variable, okay, could be converted into the standard normal variable. Now this is the formula where you would find z is equal to x minus mu upon sigma. Okay, with the help of this formula you can convert the normal variable into say the standard normal variable, right? So now what happens, okay, about the formula is that if I talk about say the fz, now what is fz? Fz is actually your we saw the probability density function, okay, with variable x. Fz is what? It is the probability density function with variable z, where you would find the x you have converted into z. So your fz is going to be equal to, actually it is the same formula, right? You would find that instead of x minus mu upon sigma, okay, z has been put up. So fz is equal to what? It is 1 upon say under root 2 pi into e raised to minus half z square, where again z you would find will lie between minus infinity and plus infinity. Now you would find while you talk about say the this is actually your standard normal curve, right? Once you convert the normal say variable into standard normal variable, okay, even you would find there are a little bit minor changes into the curve also. So this is actually your say standard normal curve, right? Again it is your bell shaped diagram, where in between you would find that z is equal to 0. Okay, onto your left hand side or extreme left hand side you need to write minus infinity because it continues, it goes on, and on the right hand side you would find it is your plus infinity. Again over here minus sign shows what? It shows you the left hand side, and plus sign shows what? It shows you the right hand side, right? Now if you talk about the area, okay, of this bell shaped diagram, okay, you would always find that the total area, okay, is always equal to 1. The total area of this bell shaped diagram is always equal to 1, right? Where you would find the left hand side, area will be always 0.5 because both the sides are equally divided. So left hand side area would be 0.5 and the right hand side area would also be 0.5 and the total area would be equal to 1, or you can say the total probability is equal to 1. Now here children, we would see the first example. Okay, what has been told, our example number 1, that a normal distribution has mean, okay, 10 and standard deviation 2. Find the probabilities of, okay, there are two sub questions. The first question is normal variable x will take value between 10 and 12 and normal variable x has the value between 8 and 10. Children, over here you would find, as it has been given, it is a normal distribution, so whatever the values have been given to us, okay, are actually x. Over here they have told your mean is 10 and standard deviation is 2. Mean is 10, that is actually your mu is 10 and your sigma is 2, right? And if I talk about, say, the first question or the first sub question, you would find, as it is they have given the normal variable x. So while I talk about 10 and 12, okay, it is actually your x. We can regard x1 as 10 and x2 as 12. Similarly, for the second question also, as it has been given normal variable x has the value between 8 and 10, we can regard x1 as 8 and x2 as 10. Children, as they had told to actually find out the probability, okay, between say the values 10 and 12, okay, between 10 and 12, okay, you would find that what we need to write over here is that, okay, you would always find that we need to find out p, say of into bracket, that is 10 less than equal to x less than equal to 12. And as I told you that as it is a normal distribution, we are talking about, say, the x. So p of, we need to write p of, we are going to find out the area between 10 and 12. So p of 10 less than equal to x less than equal to 12. Now this x we need to convert into z, that is standard normal variable, right? So how it could be done is that a p of 10 less than equal to x less than equal to 12 is equal to, over here the formula, okay, for instead of x1 and x2, over here x1 is 10 and x2 is 12. Instead of x1 and x2, we are putting up the values, that is 10 minus mu upon standard deviation less than equal to, instead of x it is x minus mu upon standard deviation, that is we need to convert it into say z, less than equal to, say instead of x2 we are going to put 12 minus mu upon standard deviation. Now in the next step it gets converted, instead of mu and sigma we are going to put up the values, that is 10 minus 10 divided by 2 less than equal to, you would find the x has been converted into z, less than equal to 12 minus the value of mu, that is 10 divided by 2. Now as you solve it, you would find we find the values for z, that 10 minus 10 divided by 2 becomes 0 and 12 minus 10 is actually 2 divided by 2 becomes 1. Okay, so what we need to find out over here, while we talk about, say, the standard normal distribution, or you can say while we talk about say the values in terms of z, we need to find out probability, okay, of 0 less than equal to z less than equal to 1, right? Now over here you would find, if we convert this one, okay, into the diagram, okay, this is how this could be put up into the diagram, right? Now putting this one into the diagram, you would find, first of all, you are going to draw the bell shaped diagram. This is the bell shaped diagram, okay, that is actually being drawn, and this would be your x axis. Okay, you will put up minus infinity, okay, onto the left hand side and the plus infinity onto the right hand side. In between that would be the middle line, which actually bifurcates this symmetrical diagram into two equal parts, where you are going to write z is equal to 0, right? Now as you see over here, okay, 0 less than equal to z less than equal to 1. So now 1 is actually your positive number. 1, where it will lie, being the positive number, it will always be onto the right hand side. So over here what they have put up on the right hand side somewhere, there is no such fixed measurement that you need to do. There on the right hand side somewhere z is equal to 1. It is from 0 to 1, 0 is there in between, and it is and 1 is onto the right hand side. So it shows what, this shows what we need to basically find out the area between 0 and 1. So that is what they have basically shaded, right? So this is how the diagram could be drawn, and you also have the marks for your diagram. All right, now over here you would find that we need to find out now in the standard normal curve table, we need to find out the value of 1. Okay, seeing to the table, right, you would find that the value of 1 will come up to say 0.3413, 0.3413, and this is actually your probability, okay, for say p of 0 less than equal to z less than equal to 1. Right, now how this values could be basically found out, that I'm going to show you, okay, right now. Here now children will see how the standard normal curve table, okay, could be used. Right, so over here once I will basically show you, okay, this table, how you're going to use it. Now in the sums, okay, whenever the values are to be found out, it has to be done in the similar fashion. Right, so I will show you the different ways of how to actually find out the different kinds of say values. Now suppose, okay, if your value is in the last sum that what we have seen, okay, the value was actually say 1. Okay, only 1 was given. Okay, there was no such numbers after the decimal point. Right, so now if we talk about 1, where is 1? So we are going to see onto the column of z. Okay, say 1 is over here, 1 is over here, right, and there was no such decimal numbers, right? So we can consider 1.00. so we are going to see this 00. So where it is intersecting, you would find the column and the row, it is intersecting over here on this number. Okay, so the value is what? The value is 0.3413. The value is 0.3413, and the same answer we had we just got in our last example that what we have seen. Similarly, if it is actually say only 1.5, say only 1.5, they have given only 1.5, nothing else. Right, now if only 1.5 is there, okay, so just see this 1.5, okay, just see this 1.5, and you are going to see 1.5 and then 0 0. Okay, the first column you are going to see. So what is the sorry, excuse me, what is the value for that? The value is 0.4332. Okay, so for 1.5 the value you are going to get 0.4332. Right, similarly children, suppose say if your number is or if your say z score is 1.83, 1.83. so what you are going to do? 1.8 is over here, 1.8. okay, how you will get 1.83? that is 1.8 plus you will do say your 0. Say 0.03, 0.03, right? You will add them, right? You will add them and you will get 1.83, right? So while we talk about 1.83, you would find this 1.8 and this column of 0.03. okay, you need to find out where it is actually intersecting, right? You would find that it is intersecting over here. It is intersecting over here. So what is your answer? Your answer is 0.4664. Your answer is 0.4664 over here, right? So that is how the different values, okay, you can find out with the help of this standard normal curve. Okay, I will take another say small example on this, right? Another small example on this. Now suppose, okay, it is 2.34. So where is the 2.3? Your 2.3 is over here. 2.34, that is 0.4 over here. See where the column and the row are intersecting? The column and the row are intersecting over here. Okay, so what is the answer over there? The answer over here is 0.4904. okay, the answer is 0.4904. That is how you are going to use the your standard normal curve table, right? So that is in all the sums, or basically the initial sums, and this is how we are going to use this say standard normal curve table, right children? So now we over here we shall see to the second sub question of the first example that what we were seeing, right? Where you would find in the first example, the second sub question was, so the normal variable x has the value between 8 and 10. Okay, it has the value between 8 and 10. So now how we are going to write it? Okay, as you know that we can write that is p of 8 less than equal to x less than equal to 10. Okay, we need to find out the area in between 8 and 10, or you can say we need to find out the probability in between the value of x's, that is 8 and 10, right? So now how it could be done? First of all, as you know now that you need to convert the x into z, right? So this is how you are going to convert x into z. Okay, that p of 8 less than equal to x less than equal to 10 is equal to p of, now instead of x1 you have put up 8, right? That is 8 minus mu upon standard deviation. Instead of say x, to convert the x into z, you have put up the formula, that is x minus mu upon standard deviation. I'm talking about to convert this x into z, and then to convert this 10, okay, into z x2, that is 10 into z2, we need to put up the values into the formula, that is 10 minus mu upon standard deviation. Okay, now we have seen, we know the value of mu was given 10 and the value of sigma was given 2, right? So you will put up the value of mu and sigma over here, that is 8 minus 10 upon say 2 less than equal to z less than equal to 10 minus 10 upon 2, right? 8 minus 10, that is minus 2 upon 2, will give you minus 1, less than equal to z less than equal to 10 minus 10 upon 2, that is 0 upon 2, will give you 0. So over here what we need to find out, we need to find out the value of z between minus 1 and 0, minus 1 and 0, right? Now we'll see how this could be converted into say the diagram. So this is the diagram, how it could be converted. Just a minute. This is a diagram, and that is how it could be converted. So over here, children, you would find because negative sign is there, it is from minus 1 to 0. Now where the negative sign would be, the negative sign should always be on to the left hand side, right? Left hand side. So how it could be done? How it could be done? Anywhere. So on the left hand side, you will take yes. First of all, so you are going to have this normal curve. Right, this is your x-axis, right? And obviously you're going to write minus infinity over your left hand side, plus infinity onto your right hand side. Now your z is equal to minus 1, so in between, first of all, your z is equal to 0 would come the vertical or the perpendicular line, okay? And on the left hand side you are going to put up minus 1, right? So we need to find out this particular area, Got that clear? Now, as I told you before, that your minus 1 is all minus sign always shows the left hand side, and positive sign always shows the right hand side. See, children, whether the area is on the left hand side or right hand side, the area or the probability is always positive. Okay, is always positive. So it's going, if whether 1 is onto the left hand side or whether 1 is onto the right hand side, the area would always come the same. So that's why over here you would find that they have put up two diagrams, okay, taking z is equal to 1 and taking z is equal to minus 1. Okay, over here the shaded part is onto the left hand side of z is equal to 0, and the shaded part is onto the right hand side of z is equal to 0. Okay, it will give you the same probability, it will give you the same answer. Okay, only the difference is the negative sign showing the left hand side and the positive sign showing the right hand side. Okay, so but just mind my words, because negative sign is there, you need to show the diagram with shaded part onto the left hand side, right? But if you talk about the area or the probability, it would always come the same, right? So over here, as we need to find out the area, right? So it is always, you would find we need to find out the area or probability between 0 and 1, and as I had shown you into the table, right, how to find out the value of 1, right? Similarly, we are going to see or check the standard normal curve table. Okay, you will always find the value for 1 is say 0.3413. The value is 0.3413. 1 3. So that is the this is actually say your second part of your example number 1. Hopefully you basically now here we shall see our third example. Okay, example number 1 and example number 2 are basically almost the same, right? So we'll see to the third example what has been given, that is the number of students in classes of higher secondary school of a city follows the normal distribution. Now mark the words, they have already told that it follows the normal distribution. They have given the average number of students in the class is 50. Okay, average number of students in the class is 50, that is they have given you mu, alright, that is mean, that is 5050, and they have also given standard deviation is 1515, that is your sigma is 15. What they given further, that if a class is selected at random, then find the following probabilities. We need to find out the following probabilities, where the first one you would find that a class consists of say more than 68 students. They have told us that the classes consist of 68 students. Now what is 68 over here? Okay, it is actually your x, right? Similarly, the second part of the question, that a class consists of less than 32 students, right? Class consists of less than 32 students. So this 32 is also what is the value of your x. Okay, doing it further, you would find had given into the sum. I'm talking about the first part of the question, that a class consists of more than 68 students. Now see children, they have given more than 68 students. Now 68 is always x, as I told you. So how we can write this, that we need to find out p of x more than equal to 68. Why? Because they have told us to find out the probability where the class consists of more than 68 students, right? Now again, yes children, we need to convert this into z. So for x, okay, you would find you have put up over here p of into bracket x minus mu upon standard deviation more than equal to. Now into the formula for x, you put up the value, that is 68, okay, in the formula of x minus mu upon standard deviation. Okay, now put up all the other values, that is you put up mean and say the value of sigma also. Here you have converted x into z. Okay, so 68 minus 50 divided by 20, you would get 1.2. So what we need to find out over here, we need to find out p of z greater than equal to 1.2. okay, z greater than equal to 1.2. right? Now how we are going to find out z greater than equal to 1.2? okay, how we are going to find it out? So over here again you would find you have the normal basically the curve, or you can say the symmetrical and diagram, where in between again your z is equal to 0, onto the left hand side negative infinity, and onto the right hand side it shows the positive infinity, right? Now see children, now just pay attention properly. Z is greater than equal to 1.2. Now 1.2 is positive, so where you would have 1.2, onto somewhere right hand side. Okay, you are going to put up z is equal to 1.2. There is no such particular measurement, okay, for this, right? And it is been given it is more than equal to 1.2, right? Now more than equal to is there, so more than is there, so always you are going to shade the right hand side. So see, this right hand side part is actually shaded. Alright, so over here we need to find out this particular area, Now how we are going to have this particular area? Okay, it is given over here. How you are going to have that particular area? Right, so what can be done over here is that first of all we can have the total area from 0 to infinity, that is 0 to infinity is actually being shaded, right? You will have this total area, right? And from that what you can do is that this much area is actually deducted, to get the shaded part. Okay, so you would find from 0 to z1 or 0 to z, this much area is deducted, and because this much area is deducted, what is being put up over here? The negative sign is put up over here, right? So that is how the diagram could be drawn. Now this diagram we need to convert it into the formula. And this diagram we need to convert it into the formula. I want to show you onto the screen the formula and the diagram simultaneously. So this is what the adjustment I have done. All right, what we have seen, first of all, from 0 we need to have the area till infinity. So you would find over here p of 0 less than equal to z less than infinity. Okay, now see children, mind my words, because it is infinity is there, you because we don't have, in infinity we don't have any exact or particular value, right? We don't put equal to sign, right? So it is always 0 less than equal to z less than infinity. Then over here, as minus sign is there, so in between minus sign is there, then what we are deducting, we are deducting the area between 0 and 1.2, right? So p of 0 less than equal to z less than equal to minus 2. Okay, that is what the formula we have written, right? Now over here children, you would find that 0 to infinity, 0 to infinity is always 0.5, as I had basically shown you say previously, right? So for this the value is 0.5, then in between minus sign, then this 1.2 you are going to see into the standard normal curve table. Okay, I showed you how you can basically detect the value. So it will give you 0.3849 seen to the standard normal curve table, right? And as you will say deduct it, you will get the answer, say 0.1151. So this is the probability, okay, and that your normal distribution x assumes the value more than 68 students. That is the probability, or the area covered is 0.1151. That's how you are going to put up the diagram and the value and formula and the value with the help of the diagram. So that one was the first part of the question, of the question number 3. Now the second part of the question, right? We'll see to the second part of the question, right, where they had given us that to find out the probability that a class consists of less than 32 students. A class consists of less than 32 students. So over here, p of x less than equal to 32. Now this we need to convert into z. That is p of, instead of x, put up the formula x minus mu upon sigma less than equal to, now into the formula put up the value of x, that is 32. Now the formula has been converted into z. Now for this 32 minus mu, okay, mu the value was 50 given and the sigma was given 20. So 30 minus 50, 32 minus 50 upon 20. Okay, as you will solve it, z less than equal to minus 1.2, z less than equal to say minus 1.2, right? Now this how we are going to put up into the diagram, right? So into the diagram you would find, okay, into the diagram you would find, see, p of z less than equal to minus 1.2. So again you are going to have this symmetrical diagram, your x-axis, say where z is equal to 0, minus infinity into the left hand extreme corner, and the positive infinity. Minus 1.2, negative sign is there, yes, it shows the left hand side. So in between, where anywhere you are going to put up negative 1.2, and as it is showing that less than equal to, so the less than, that is the whole left hand side would be shaded, right? So this left hand side, okay, is to be shaded, and we need to actually find out the probability or the area of this shaded part, right? Now how this could be done, or how this shaded part could be found out, right? So let me have the two diagrams also onto the screen. Yes. Now you would find, to get only this much shaded part, what we need to have is that, first of all, we need to take from infinity till 0, we need to take the area, right? And then, okay, what we need to do, after taking this whole left hand side area up to z is equal to 0, right, the white portion that you are seeing over here, this white portion that you are seeing over here, that has to be deducted. Okay, so this has been shown over here. This portion has to be deducted, that is minus sign in between, alright. So that is how you are going to get this particular diagram, right? So now how this one can be converted into the formula. Okay, so I want to have these two diagrams because I need to show you the formula, how you are going to write the formula for the same. Now see, what we have taken from the infinity over here, we have taken till 0. So see the formula. Say a p of minus infinity less than z less than equal to 0. As I told you, wherever the infinity sign is there, okay, no need to keep the equal to sign. Then in between the negative sign is there, so you put up the negative sign, and then you would find, children, over here from minus 2 to 0, minus 1.2 to 0. So over here you would find that p of minus 1.2 less than equal to z less than equal to 0, right? So now what we need to have is that we'll see over here, children, you would find as infinity to 0 is always equal to 0.5, that is 0.5 over here in between minus sign. Now children, you would find, as I told you, that negative sign always shows the left hand side and positive sign always shows the right hand side, but the area, the value of the area will always remain the same. So that's why you would find over here this one, negative 1, is converted into positive, that is minus p of 0 less than equal to z less than equal to 1.2, right? So now in the next step you would find 0.5 minus this 1.2, as you will see into the standard normal curve table. 1.2, the value is 0.3849, so that particular value you are going to deduct from 0.5. Your final answer is what? Your final answer is 0.1151. That is the same answer that you got actually for the first sub question. So the you would find the probability for the class which consists of say less than say 32 students is what? It is also say 1151, right? Here now children, we shall see to the fifth example. Okay, this example is a little bit different than what the example we have seen the last one, right? What they given over here, see to the fifth example, you would find that there's also one of the practical examples given into the book. The monthly income of the workers working in a production house follows the normal distribution. They are told that it follows the normal distribution, that average monthly income is 15,000 rupees and the standard deviation is rupees 4,000. They have already given the average, that is mu, and standard deviation they have given. Your mu is rupees 15,000 and your sigma is rupees 4,000. Alright, then see the first question. What they are given, that if a worker is selected at random, then find out the probability that his monthly income is in between rupees 10,000 and 25,000. So over here also we need to find out the probability. So over here your x1 is 10,000 and your x2 is what? Is 25,000. This is the first part of the question. Second part of the question, now see, this is different. They have told over here find out the percentage. Till now we had found out the probability or the area. Over here they have told that find the percentage of the workers having the monthly income between say 12,000 and say 22,000. So we need to find out the probability or the area. This 12,000 and 22,000 rupees are what? These are actually your x1 and x2. So we need to find out the probability and then we need to find out the percentage for the same, right? So now let us see this example, how to solve it. Just again, our mu is what? Rupees 15,000 and our standard deviation is what? Is actually 4,000, right? Now how we are going to have this, how we are going to write this? Okay, over here you would find the first I'm talking about the first question, children. We need to have the area between rupees 10,000 and 25,000. So we need to have p of say into bracket 10,000 less than equal to x less than equal to 25,000, right? Now this we need to convert into z. So into the formula you are going to put up the value of 10,000, put up the value of mu also and sigma also, that is 15,000 and 4,000. Over here for x you are going to have it the formula, and for x2 25,000 again you are going to put up into the formula. You will have say your sigma also and your mu also. Then solve this. Okay, you need to basically solve all this, right? Say solving all this you would find that you will get minus 1.25 less than equal to z less than equal to 2.5. Now this area we need to find out, the area between minus 1.25 and 2.5 we need to find out. We need to have the area, or you can say we need to find out the probability for the same, right? Now how to have it into the diagram, how we can have this into the diagram? right? So minus 1.25, okay. First of all, again your normal distribution curve, x-axis minus infinity plus infinity, in between z is equal to 0, right? Say it's minus 1.25. Again, minus sign shows what? The left hand side. So somewhere over here you are having this minus 1.25 that you can denote as z1, and 2.5 onto the right hand side somewhere, right? That you can denote by z2 is equal to 2.2. It means what? We need to have this whole area, or we need to find out the probability of this whole area. Was that clear? Right? So now how you're going to basically have this area? Okay, this area you can have first of all we'll go from minus 1.25 to 0. First of all, you are going to go from minus 1.25 to 0, this much of area. Then from 0 you are going to go to 2.5. You are going to find out this much area, and you are going to add them. As you will add this both of them, okay, you will get this whole area. You will get this whole area. Got that clear? So just we'll see to this how it has been done. See, this is a whole, that particular thing has been shown, right? What I have shown, right? You are going to have from minus 1.25 to 0, and then 0 to 2.5. This you are going to merge means you are going to add, right? So see this, p of minus 1.25 less than equal to z less than equal to 0 plus 0 less than equal to z less than equal to 2.5. this you are going to add, right? And as I told you, the negative one is converted into the positive. So 0 less than equal to z less than equal to 1.25 plus 0 less than equal to z less than equal to 2.5. Again, the value of 1.25 and 2.5 we are going to see into the standard normal curve say table, right? So you would get say 0.3944 plus 0.4938. You will add them. The final answer is what? The final answer is 0.8882. Okay, this is the final answer that the probability that we are finding, okay, for the monthly income between rupees 10,000 and rupees 25,000, right? So this is the first sub question, right? This is the first sub question. Come to the second sub question. This is the second sub question below, right? Now in the second sub question, okay, that told us to find out the percentage, in fact. So first of all, we need to have the area between 12,000 and 22,000. So how we can write? P of 12,000 less than equal to x less than equal to 22,000. Okay, put it into the formula, right? Have the values of mu and standard deviation, get the x converted into z. So you will get minus 0.75 less than equal to z less than equal to 1.75, right? Now how you are going to have this, okay, into the diagrammatically or into the diagrammatic form, how you are going to have this, right? So over here it is, right? So you would find again the curve you are going to draw, minus 0.75 which shows the left hand side. So your z1 we have put up minus 0.75. 1.75 is the positive value you are going to have onto the right hand side of 0 somewhere over here. So in short, what we need to have, we need to have this shaded part. We need to have this shaded part where in between your z is equal to 0. So again, for this, what we need to do, this area you would find that this area and this part we are going to add. Okay, we are going to add. So see this diagram, the same diagram what I have told you, okay, but the diagrams are added to actually get the final answer. All right. So now how say we are going to put up the formula. Okay, actually it is getting hidden. Okay, fine. So over here, just let me zoom for you, zoom it for you. You can't see. Okay, never mind. See over here that P of minus 0.75 less than equal to z less than equal to 0 plus what? Plus you would find that from 0 to 1.75, so P of 0 less than equal to z less than equal to 1.75. the negative value we are going to have it into positive. So p of 0 less than equal to z less than equal to 0.75 plus p of 0 less than equal to z less than equal to 1.75. Right, now this values again, what you are going to do, you are going to see at the back into the standard normal curve table and get the answer. So what answer you are going to get for this, okay, is actually, I will write it over here and I will show that the answer that you are going to get is 0.2734, okay, for 0 less than equal to z less than equal to 0.75, okay, plus now as you will see to the table 0.75, the value that you are going to get is what is 0.4599. you are going to get 0.4599, and as you will add them, children, you will get something like 0.7333. so this is your final answer, 0.7333. There's the probability, okay, for the income between 12,000 and 22,000. But children, they have told you to find out the percentage. So to find out the percentage, what you need to do is that this 0.7333 you are going to multiply it by 100, because we need to convert it into percentage. So as you will multiply this by 100, you will get 73.33 percentage. So this is how we converted the area or the probability into the percentage. So that is how we can get the answer for the second sub question. That's the example number 5 for you. So children, today we are going to stop the video over here. In the next video, you would find the properties of the normal distribution and the properties of the standard normal distribution, and you will have the sums further. Right. So for time being, goodbye. God bless you all.